Hello learners, welcome back to my channel Learning with Nirvan. So today I'm going to teach the exercise 1.1 of the first chapter of class 9, that is number system. So the first question in exercise 1.1 is 0 a rational number? Can you write it in the form of P by Q, where P and Q are integers and Q is not equal to 0? Okay, first of all, rational numbers. What are rational numbers? Rational numbers are those numbers that can be written in the form of P by Q, and where this P and Q are integers. Okay, we have learned it in the previous video. Okay, and this Q, the denominator, shouldn't be is equal to 0. It shouldn't be 0. Okay, we can suppose that 0. For example, 0 is a number we have given here. We need to say 0 is a rational number. Okay, so we have taken 0. For example, we can say 0 upon 1. We always write. Okay, we can write 0 upon 4, 0 upon 3, and so on. So hence I can say that we can write 0 as a rational number, and 0 is a rational number. Hence 0 is a rational number. So coming to our second question. The second question is find 6 rational numbers between 3 and 4. We have learned another method in class 8. We have used it. But in class 9, it is the same type of a question. Okay, here what we'll do, we have two numbers, that is number 3 and number 4. Okay, so in number 3, what we'll do, 3 is the denominator is always 1. When a number is written only in a single form, or it is just a whole number, we can write, suppose that the denominator is 1. Alright, so here we need to find 6 rational numbers. So here so there is nothing. Okay, so what we need to do, that we need to change the denominator, multiply it with the numerator, and the denominator should be same. In both the cases the denominator should be same. Here right now it is 1 here, it is 1 here. Alright, but what we need to do is multiply with a such number that again the denominator would be same. Okay, what I am going to multiply here, if I multiply it with 7, 3 upon 1 into 7 upon 7, and here what I am going to do, 4 upon 1 into 7 upon 7. What am I going to get here is 28 upon 7, and I'll get here 21 upon 7. Now they are asking 6 rational number, so we can write numbers 6 numbers are 22 upon 7, 23 upon 7, 24 upon 7, 25, 26, and we can also write 21 upon 7 here. Okay, so there are 1, 2, 3, 4, 5, 6. We have 6 numbers here, and the questions are 6 numbers. So okay, the third question is find 5 rational numbers between 3 upon 5 and 4 upon 5. Okay, in the last question what we did, we had two numbers, that was only 3 and 4. They both were in whole numbers, but here it is given in fractions. Okay, just don't be afraid, it's a very simple question. We'll use the same method by which we'll find or we'll multiply a number which the denominator would be same. Here the numbers are 3 upon 5 and 4 upon 5. Here the denominators are already same, but again we'll multiply both the numbers with such a number that the denominators would again be same. Okay, we need to find 5 rational numbers, so we need to keep that in mind. Okay, if we multiply this number 3 upon 5 into 2, then we are getting only 6 upon 10. And on the other hand, 4 upon 5, if we multiply with 2 upon 2, we get 8 upon 10. Okay, but there we have here only 2 numbers, but we need to find 5. So here we cannot use this method. Okay, so we'll multiply the number with some other number. Okay, so what we had 3 upon 5 and we had 4 upon 5. What if we multiply both the sides with 10? when we multiply with 10, we'll get 30 upon 50. And on the other hand, we'll get 40 upon 50. So have you noticed one thing? That these denominators are same on the both sides. Okay. So here, if we need to find 5 rational numbers, how can we find? Numbers are, the numbers would be 31 upon 50, 32 upon 50, 33 upon 50, 34 upon 50, 35 upon 50. So these are the 5 numbers, rational numbers between these two numbers. They are infinite numbers, as I told you earlier. So this is the method. Okay. Coming to our last and final question, that is question number 4. State whether the following statements are true or false. Give reasons for your answers. Let's read first. First, every natural number is a whole number. Second, every integer is a whole number. Third, every rational number is a whole number. Okay, first and foremost, let's know what's natural and whole numbers. Okay, rational numbers that we come up naturally. Like if somebody says counting bolo, so what you will say? 1, 2, 3, 4. We'll start with 1. So for just remembering, you'll just say that natural numbers are those numbers that we start with number 1. That does not include 0. Okay, just imagine natural numbers. We start from 1, 2, 3 and infinite. Okay, there are infinite numbers, as you know. And whole numbers. Okay, whole numbers are the numbers that include 0. Whole numbers that include 0, then 1, 2, 3 and so on. Okay, so here every natural number is a whole number, because as we know that all the natural number is a whole number, since 1, 2, 3 and here is 0. So hence it is a true statement. Right? True. Okay. Second, every integer is a whole number. Now there are 2 types of integers. Integers, there are 2 types. One is positive and the second one is negative. Negative integers and positive integers. Okay. Positives that we write in plus, we generally say plus 1, 2, 3, 4 and rest is minus 1, 2, 3, 4 etc. Okay. Every integer is a whole number. Okay. Whole number includes positive numbers. Okay. It does not include negatives. So hence it is a false, because it does not include negatives. Okay. So here we can write as a false statement. Every rational number is a whole number. Rational number we have learned, which we can write in the form of P by Q, and P and Q are integers and Q is not equal to 0. Okay. So it is a whole number. Okay. Not all rational numbers are whole numbers. Alright. Because for example, if I say 2 is a rational number, since we can write it 2 upon 1. But if just imagine that I can write 6 upon 7. Is it a whole number? It is the rational number, but it is not a whole number. Hence, this is also a false statement. That's all for this video, and I hope you like this, and the rest upcoming exercises will come up in the next video. Till then, see you soon. This was all for this exercise 1.1 of number system. Till then, thanks for watching. Do like, share and subscribe. Till then, learn, play and enjoy. Thank you.